All right, guys. Well, welcome to the third remote DataOpsDC. So we've been having remote meetings since March. So I think we're pretty used to this by now. I like to always say what DataOps is. It's just not about DevOps for data. It's really a transformation of thought of how you organize your data to create value for an organization and allow your developers to walk without fear of messing things up. So this meetup has been going on since, I want to say last year, August. So definitely starting to pick up some steam. DataOps is becoming more mainstream. I even started a DataOps podcast, so be sure to check that out as well. DataOps is the future, and that's why you guys are here. So I'm always looking for speakers and topics and sponsors. It was great. Yellowbrick Technology was able to sponsor today and their generous donation. That was awesome. So way to go, guys.
Thank you, Banjo.
And we have a couple people on the line have actually spoken at this meetup before. We used to have 2 speakers when we got to meet in person, but it's been harder to find speakers on virtual, so I've been having 1 speaker. But if anyone's interested in just talking, I'm interested in learning more about what you got to say, and you can present to the meetup. So please reach out to me. Yeah. And today we have great speakers, so I'll let you guys go on. Let me stop sharing now. So Adam, Prema, when you guys are ready, feel free to take it away.
All right, take it away, Adam.
Great. 1 second. Okay. Okay. Thank you. I was like, that really, shot through my system. So thank you for your understanding and your patience, and thank you for having us here. We are so excited to be here tonight. So our presentation is called Machine Learning Visualization with Yellowbrick. And as data ops people, and Prema and I read through the manifesto before we came, I think you're going to find that Yellowbrick fits very nicely into the data ops principles. And our goal, and the goal of Yellowbrick, I'll say real briefly, is to supplement your existing data science workflow. It's not to replace. We don't seek to replace. We seek to supplement. We seek to help. We seek to better help you achieve better machine learning, modeling results, and other, through every step, end to end, visually. So I'll say that. And so tonight, Prema Roman, she's a maintainer. She's a lead data engineer at Excella. She's awesome. And there's her contact information. Myself.
Hey, everyone.
Yeah. Oh, yeah.
Hey. Oh, yeah. So real quick, I also just wanted to just mention, I think you guys might be seeing in the chat, have my coworkers, Eric Schiller and Cassandra Fang, in the group as well. And Eric has posted out that Excella is hiring. So if you guys are interested in working with us, definitely check out the careers page.
That's awesome. That's awesome. So I'm Adam Morris. I'm studied now. Lead data scientist, Booz Allen Hamilton. I'm also involved with the Georgetown Data Science Certificate Program as a capstone advisor, and I'm a contributor and advisory board member for Yellowbrick. That's my info. Also, so Kristen McIntyre is in the audience tonight. She contributed to this deck, so we wanted to mention her, and she is also a data scientist at Booz Allen. She's an adjunct lecturer at Georgetown and a core contributor and our advisory board chair at Yellowbrick, and she's awesome. There's her information there. Thanks, Kristen. So if you think about your ideal data science workflow, right? It probably looks something like this, question mark. You can't see me, but I'm saying ideal with quotes. I think the elements are there. The elements are definitely there, but perhaps it's not as nice and neat and as clean as this diagram, right? With the arrows, the one directional arrows. So, problem statement, hypothesis. But I mean, on the positive, right? The elements are there. And so So you have to have a workflow. But as I said from the beginning, Yellowbrick seeks to supplement, not replace your workflow. So so what is Yellowbrick? So this is what we're offering tonight is a different vision for your workflow. So again, not to replace it, but just a different way to look at it visually. And if you think about Yellowbrick and the Wizard of Oz and the Yellowbrick Road, then that's kind of our driver visually. You know, from feature engineering to model selection, hyperparameter tuning, dimensionality reduction leads to better model results visually. So what is Yellowbrick? Yellowbrick is a Python open source library that allows users like you to steer model selection process. It's powered by Scikit-Learn and Matplotlib. It was created by Dr. Benjamin Bangfort and Dr. Rebecca Bilbrow, who are both they're both faculty, key faculty at the Georgetown Data Science Certificate program at SCS. And so they came together to create this library, Python library, you know, with the goal of supplementing the machine learning process, also with the goal of being accessible to, you know, data scientists, data enthusiasts at all levels. And as you may know, or may not, we are a NumFocus affiliated project, proud to be that, and that we also have a local, we got started with the local affiliation group through the district data labs, district being DC. So we play nice. Our interface is very similar to the interfaces that you know. If you think about the Scikit-Learn interface on the left, looks familiar, right? Through three major lines of code, you know, from import to instantiation to fitting, .fit method on X-train, Y-train, and then .predictor. And so you can take that workflow and move it from left to right into the Yellowbrick interface, right, to our API. So basically, you can just move it to the right and then just add in Yellowbrick commands. So like, for example, so we have, so our plots, our machine learning plots are called visualizers. And so, you know, as you can see, you're doing the import statement, you're instantiating the prediction error visualizer, right? So visualizer equals prediction error. And also importantly, you're wrapping in your scikit-learn model, as you can see, models in parentheses. So then you're just simply calling fit and score, as you know to do. And then we have something called .show, which generates the plot. So as a demonstration, let's take a look at lone default prediction Kaggle competition. The goal of this was to predict any amount of default. And so any default over 0 for like lenders. So there was a data set that they used. If you don't know, you probably do. Kaggle is a warehouse or an online repository of data that is available for teams to, you know, to ingest and analyze and to come up with creative solutions. And sometimes you can win money. So it's very cool. But anyway, so that's the goal of this data set, and starts out very familiar, right? So we're big on using familiar codes, such as using pandas, you know, in a Jupyter notebook. So you import it, and then you read it, you know, read in the data frame. And let's take a look. And wow, there's a lot of columns here, 771, and we have some missing values as well. When you do the head and .describe methods. So let's keep going. So let's see like what we might be able to do with this. So how about we turn this into a classification problem instead, right? So our goal or our target is finding those folks who defaulted. So it would be a default _ yes class, and we're going to do encoding. So if they don't default, 0, 1 if they do, right? Just a simple example just to show you how Yellowbrick can help. And So we'll start out by using Yellowbrick to do some feature analysis with our joint plot visualizer. And so we can select 2 columns. Of course, the columns are randomized, so we don't know. We don't know what the columns are. So we can just choose F1 and F4, right? And it's the same. It's the same steps as when we, introduce. Basically, you're setting the target, you're setting the features as X, target as Y. You instantiate the visualizer, specifying the columns, and then you call fit_transform XY, and you show. And this is the result. And as you can see, the Pearson score is 0.782. So there could be some relationship here. And so also looking at the, there's also note that there's the histogram at the top so that you can see how the data is distributed. So let's keep going. Let's do some more. So we'll pick 2 other columns, F2 and F13, and we'll run it again. And we can see a very different score. So these 2 columns don't seem to have much of a relationship. In fact, a negative 0.063 Pearson score. And as you can see, right? So we're adding, the value add is the visual component. So we're showing like how the plots are spread out further apart, and just shows like a lack of a strong relationship. So we'll keep going, and go to the next. We'll go to the end. As we said, there's many columns, so we'll pick the last 2 and run it. And here, again, we can visualize and see that there's almost a perfectly inverse relationship, negative 0.99999 Pearson score. And so, but isn't it nice to be able to see this and to get the feedback? So, if you think about the feedback that you might be getting right now, if you're not using Yellowbrick or a product like Yellowbrick, you can get the Pearson score, you can get, a report, but it's not going to look like this. You're not going to be able to see, and also with the histogram on top, you can see like the distribution of the data there. So, so now that we did that, now that we did some feature analysis, let's keep going and do some target analysis. Also, just so you know, we'll hold the questions until the end. And thanks. And so we'll use the ClassBalance Visualizer, right? So we want to see how the data is distributed between the 2 classes, default underscore no and default underscore yes. So again, it's the same task. We're doing the import. We're setting our features as X, our target, which is lone default, as Y, creating the classes, default no and yes, instantiating the visualizer, setting classes as classes, and then 3 lines of code, just like Scikit-Learn, 3 lines of code. Dot fit on the target and dot show. And let's see what we get. Whoa, there is a class imbalance problem here. This is going to make things pretty dicey, perhaps. But again, so we called the class balance visualizer, and so this is the result. So like again, what we're giving you is visual diagnostics of your data. So we can see there's a big class imbalance. Let's see how we can address that. So now we're going to select a subset of the features. So the features that seem to have relations, good relationships, and stratify them. Doing train and test sets on the target variable. And so Of course, stratifying is just making sure, that's the 80-20, just making sure that, it's 80% train, 20% test. And so, we set our X and Y, X train, X test, Y train, Y test, just as you would do with Scikit-Learn. And so, so we set that up. We specify the columns. We're going to run it now. And before we show you the results, just a quick refresher on classifier evaluation metrics. So as you know, precision, we have, precision recall at F1, which shows the overall strength of the model. And we have support. The support column shows the class balance. So, it's just another way to sort of like give you the numbers and show you like, how many instances belong to each class. So that's just a refresher there. And so we ran it. We ran the classification report visualizer. Here's the results. It's not looking good, is it? It's not looking good for default for our target variable. In fact, seems like we tried logistic regression classification, which is, as you know, classification, not regression. And we got zeros on the target class. It did a pretty good job of determining or the class that wasn't target, default _ no, but of course that's not our goal, right? So as the support column demonstrates, the magnitude, it really demonstrates like the magnitude of the class imbalance problem that we're facing. And so, with over 19,000 instances in the, default no class, but only 1957 that we're trying to pick out. And so that's hard, right? It's hard to do. But so we also tried the extra tree classifiers, which is like an aggregation of decision tree models that are aggregated and scored. And we got similar results, slightly better, but still pretty dismal results here in terms of predicting our target. But again, thinking about Yellowbrick, isn't it nice that we can have these, the visualization, the plot, the diagnostics, right? It's not something that you get in your typical workflow. So let's try something else. Let's try the Xgboost model. And good news, Xgboost and Yellowbrick work together. So that is good. So we, import Xgboost classifier and we set it, and we fit the model on X train, Y train, and then from there we're going to wrap that in. So we're going to wrap that into Yellowbrick. So Yellowbrick is set up to be able to have that wrapped in, and so it's notated Xgboost model, just as before, right? So you instantiate the visualizer, you fit it on X train, Y train, you score it, X test, Y test, and you show. And let's see how we did. Oh, not looking much better again. So we have the same zeros on the target. We have the same class imbalance. The same kind of performance. Actually, it's very similar to the logistic regression performance. And so, so we're struggling here. So we're struggling, but, again, we're using Yellowbrick so we can see the results and, with the heat map here in the classification report, which is nice, I mean, that is nice, but we still have to solve our problem. It doesn't solve our problem. So with this, to tell us about what kind of solutions we might be able to come up with, I'm going to turn it over to my colleague, Prema.
Oh, great, thanks, Adam. I'm going to go ahead and share my screen here real quick. All right. All right, so far we're not doing so great, are we? We've tried a few different things, and we can see at every step, like we've kind of used Yellowbrick to see, how well we're performing, and it's not doing so well. And definitely these models are suffering from the class balance problem. So one way to kind of mitigate that is to try to oversample the minority class. And one of the ways you can do that is to use SMOTE from the Xgboost library. And so we basically take the original data set, pass it to smote.fit resample, and then now let's kind of see what the class balance looks like. And by passing it the ClassBalance Visualizer, we can see that now the number of instances that are attributed to both of the classes are more even. And you can also see that the total number of instances are higher than they were before. So that's one way to just kind of look at the differences here, just kind of visually. So now let's take this data set and see how our models perform against this newly created data set. So here we have the Xgboost classifier classification report, and you can just see right off the bat, even without looking at the numbers themselves, that the results are much better, because you can see kind of like the darker colors of blue here, which are closer to your 100%. What we also have here on the right, which I'm sure a lot of you are familiar with, is the confusion matrix. So we have the confusion matrix visualizer to help evaluate classify models. So the true classes here along the left, and then the predicted classes here along the bottom. And so what that basically means is that all these values here on the left diagonal are all the number of instances that were accurately predicted. And then along the right diagonal are the instances that were incorrectly predicted. So just taking a look at the left here real quick on the classification report visualizer, we can see, first of all, like the support is changed here. We can see that the numbers, the number of instances attributed to both the classes are almost even. We can see that the recall score for the class that we care about is higher, and we can see just overall the precision and the recall and the F1 scores are better. But again, when you look at the numbers here, you can see that there's still room for improvement, right? Because like the one that's particularly problematic here, which is what we highlighting here, is the fact that there are over 11,000 instances that these are like people who had not defaulted but are being classified as having defaulted. That's problematic on a couple of fronts. On the first case, it's an opportunity cost for the lender, because these are customers that the lender can go after and get business from, because they can lend money to these people and they would pay money back. And also, it's even more problematic is that you're kind of leaving the subset of your customer base from that market, and that would not be fair if a model like this were actually put out in production. So again, just kind of looking at using these visualizers to kind of look for these things and seeing, are we on the right track? It's actually a good way to do this. So let's take a look at how the extra trees classifier performed. And well, actually, if you can see here, it's did a lot better. We have across the board the precision, recall, and the F1 scores all in the 80%. And then along the left diagonal, you can see a much higher, like with the really dark shade of blue, you can see a good number of instances were predicted accurately. And conversely, the number of instances that were predicted inaccurately are a lot lower. So hey, there you go, we're on the right track, I think. So that's what we can see kind of quickly here with the visual report. So how about though, we were able to achieve these results because we had created a new synthetically created data set. But how about we had the original data set and we want to try to see if there's a way we can still improve performance given the kind of data set that we have, because in reality, most people don't default, right? It's really going to be a really small segment of the population that would default. So it turns out that Xgboost, kind of doing some research on it, has functionality to deal with imbalanced classes. So there's a parameter called scale pos weight that kind of uses that ratio of the two classes to account for that. And so we can try to use this to see if the Xgboost classifier works better. And so really all we have to do is introduce this parameter to the classifier, and then go ahead and pass it to the classification report visualizer. And one thing to note is that I have not included it here, but literally like the only thing to generate the confusion matrix is to import confusion matrix, and then just instead of classification report, you just call confusion matrix, and everything else is exactly the same to create the confusion matrix visualizer. Oh boy, so this does not look so great. In fact, just looking at this number right here on the far right, it looks like we went to the other extreme, where the model seemed to overly want to predict everybody as having defaulted, which is pretty bad. And you can see kind of like with some of these, their lower scores is not so great. So what happened? Well, this is what happens when you just simply copy and paste from the website and don't really do enough research on like what exactly, how exactly this parameter is used. And so it turns out that the actual, the more appropriate value for that parameter is 10 rather than 100, because it's supposed to be the total number of negative examples divided by the total number of positive examples. And so by putting that, we can see that compared to the previous visualizer where you saw the numbers were really bad, we've actually at least gotten some improvement here. But again, like looking at this, there's still obviously more room for improvement. And so really, what it is, especially in the case of Xgboost, is that it in general doesn't perform well with the default hyperparameters. There's a lot of hyperparameters that you can tune for the Xgboost classifier model. So definitely doing some tuning would be a good place to go, and maybe doing some more feature engineering, trying to see maybe if there's a different set of features that might be better, or doing some sort of dimensional reduction techniques. That could work out as well. And so with that, we'd like to hope that the examples that we have shown you today demonstrate that Yellowbrick is an essential tool in a machine learning workflow. And the use of visual steering, as we have seen with these examples, enables data scientists to make more informed decisions. Because each step of the way, you're kind of using these visuals to kind of guide your way to take the next steps. And one thing also to note, like we haven't demonstrated here, but Yellowbrick also has a lot of visualizers for hyperparameter tuning. So for example, there's clustering visualizers for, say, identifying the ideal value for K, and K means clustering. And again, like rather than having to kind of go blindfoldedly, you can use a visual way to kind of quickly guide you along the right path. And also, Yellowbrick can be incorporated as part of a quality monitoring system to evaluate models during training, and also to detect model drift during production. Again, you can take these visuals and you can save them, and then you can, when you run your pipeline again, you can look at the visuals. And one way, especially, and to detect model drift would be like kind of looking using the joint plot visualizers, for example, where you could see the relationships between pairwise features, and see if those relationships are still kind of the same, or they've changed. So that would indicate like a change in the kind of data set that we're seeing in production, right? So that's definitely one way you can very quickly see if there's something that's different about the data that's in production. And as we have demonstrated through these examples, that Yellowbrick is pretty simple to use, but it's also customizable for advanced users who want more control over the plots. But also, because Yellowbrick extends the Scikit-Learn pipeline, the Scikit-Learn, you can actually add Yellowbrick into a Scikit-Learn pipeline object and kind of really build out your complex pipelines and add Yellowbrick at the end, so where you get to fit the model, train the model, and then evaluate the model, all in a more automated fashion. So along the lines of you using a more data ops like workflow. And so with that, we'll open up the floor for questions.
Question in chat is, what type of customizations can be added to the visualization?
So there's like matplotlib parameters that you can use. Like there's people who are kind of more familiar with matplotlib and want like certain types of, maybe like in terms of the size of the plot, or some kinds of coloring and things like that. There's things that you can actually pass through, like keyword arguments, or even some specific visualizers have some some other parameters that you can include to make the plot more customizable for your particular use case.
To follow up to that question, is it possible to add Seaborn to this as a wrapper over matplotlib to get the improved default visualizations, or is that a little trickier?
No, I think it would be trickier because I think Seaborn has its own API, which is not quite the same as our API.
That makes sense.
And it would be kind of nice. There are some things like that Seaborn has that could, but I guess that's for like, I think you could probably have Seaborn for some of the things around the features, and then kind of add Yellowbrick on for some of these other more model evaluate, like kind of looking at more features, multiple features, and also model evaluation, hyperparameter tuning, things like that. So there's definitely multiple tools that can be used here.
And I have another question. For integrating Yellowbrick into a pipeline, is it possible to format the outputted charts into some kind of report, like a PDF or something?
Yeah, so there's a way you can save these visualizers as PNGs, and especially like if you're if you want to build like multiple visualizers, like the specific example that I use in our project, we had both like what you call it, the classification report, the confusion matrix, and the Rockoff curve, and we just used something in Yellowbrick called the visualizer grid that will actually put all of those three kind of together, and so you can kind of use that to compare all the results.
Very cool. Thank you.
So as kind of a follow-up to that, what does the obviously I know what graphic formats look like, but in terms of, can you also save off what it spits out kind of for the data and pieces like that for essentially versioning data, and also some of the code that generates that, obviously kind of also being able to kind of merge that back in as necessary?
Right, actually, good question, Eric. So it turns out I actually talked to Rebecca Bilbro, who's one of the co-creators for Yellowbrick, and I mean there's definitely a lot of like versioning tools that exist that you can use for, but what's nice is you don't so in my project, we're kind of doing a kind of like a homegrown versioning solution. Just because since you can save these PNGs, you could, what we're basically doing is appending the PNG, the name of the PNG with like the timestamp of like when these visualizers were generated. Mm-hmm. So that way, and then you can save these off, and then the next time you run the same the model of different versions, like you can have a different timestamp, and then you can kind of use that as a way to like mm-hmm. compare different versions.
Cool.
And so in talking to Rebecca, it turns out that she was actually doing something quite similar in her projects as well.
Cool.
Another question, I guess since Yellowbrick is open source, can you talk about how that's developed and how you find what features to build and how you go about, I guess, developing the whole application?
Sure. Hey, Adam, would you like to take that one?
Sure. So yeah, open source, as you said. So we have a group of committed folks, just as any open source contributors, any open source project. So I guess is your question like, how do we how do we decide like what we're going to pursue and like what we're going to like try to build out? Is that kind
Yeah,
of
like your roadmap, what you're building, who gets what, priority, etc.
Yeah. So yes. Yeah. So we kind of work in sprints. Like we used to be kind of a less formal group. We have added formality, and so we have a board structure now. As Yellowbrick grew, so that was we kind of transitioned to that. So we meet once a quarter, and of course we have a Slack channel. We have I'm not quite sure of the number. Prema, do you know the number of contributors that we have right now? Like core contributors?
Oh gosh, I actually don't know that number off the top of my head.
Yeah, I think it's at least, yes. So like anyway, so we have a group of them. And so like so part of it is like, when we get issues, bugs, issue requests that come in on our GitHub, so we will work to make those fixes. So like that's part of it. Or people will request certain features or visualizers. I think also I would say take a scholarly approach as well, and like we read papers and stuff. So like we're looking at different like trying to think about, well, what kind of functionality would it be nice? For example, like there was an interest like when we were developing the PCA, right? So we didn't always have principal component analysis. We wanted to do a visualizer that helped with that work. And so like that was something that was like collaborative and noted as a priority that we move forward. So that's like one I can think of. We have others. We built out the ClassBalance Visualizer that you saw in the presentation today. So like we have like a group, and we kind of have group norms. We kind of get together. We talk about what we're going to prioritize, what we're going to put on the back burner. One of our recent efforts was with quick methods in our latest release. So we made an effort to we call them one-liners or quick methods for the visualizers, which is basically like a preset, right? So like if you call like a way to like generate your plot more quickly without a lot of customization, because like we put out a poll amongst our contributors, and that was something that was stated as of interest. So that's something that we worked hard to do, and we moved the ball forward on that. So that's like one example. I have others, but and also we engage in the community. We engage on Twitter. We go to these talks. We hear and so like if you have any suggestions or ideas, we invite you to go to our GitHub page. Be sure to star the GitHub page and to open up a pull request if you like can see or can think of like a way to improve. Like we rely on you. Like we rely on each other, but we rely on folks like you as well. So we're very open, and we actually in our docs have a contributing section that will walk you through our process, and we are there to support. If you have questions, you can post a question to our GitHub page. We have a Google Groups page. We have the Twitter account. So like we're trying to be in touch with our users. It's not like we're not doing this in a vacuum. Like we're talking to each other. We're talking to users. We're getting ideas from users and trying to make those improvements. Anything you want to add, Prema?
I guess like the one thing I would say that was one kind of what should I say, like kind of community building that was actually particularly a lot of fun in the last couple of years was the the sprints that we did at PyCon. In fact, like 2 years ago, especially it was like the first time that I got to go to PyCon, and so we had a couple of days of sprints, and we had a bunch of contributors come in over those 2 days to like add code to our repo, and just had great time just writing code together. And we had in both years we actually had Guido come in and like do a guest appearance at our sprint, and I was so looking forward to it this year, but unfortunately COVID hit, and that kind of went out of the water. So but what do you do? But
we actually had an overflow room. I mean, it was pretty great. It was pretty great. And also like we have like, so we try to present at conferences as well. And like PyCon, like PyData DC, and other PyDatas as well. And so like, so there's a lot of like interaction that goes on at those events. And so we try to collect feedback. Like we usually try and get a booth in the exhibitor hall. And so we talk to folks. We're always talking to folks. So if you got an idea, want to make it better, our response is check out our docs, do the quick start tutorial, check out our contributing section. We spent a lot of time on the docs, so like we try to make it easy, step by step. Like this is the steps. And also if you get stuck, like reach out for support. And if you can't do like a whole visualizer on your first pass, if you can just do one piece of either a visualizer or solving a bug or what have you, like we welcome that. We will champion you and support you.
Any more questions?
What are you all most excited for in terms of upcoming Yellowbrick development? What's on the horizon that's really exciting?
That is a great question. We have a list of visualizers that we have identified that and kind of split up that we are going to work on. I'll be honest that I think COVID, unfortunately, is taking a toll on, as I'm sure everybody in the room, it's been hard. It's made things a little bit harder. But we're not giving up. And so we did set a direction. And so we did identify some visualizers. So I think working through the list of those, I think also doing talks like these, spreading the word is exciting. One of our co-founders is doing a talk next month on a different meetup. I could send that out or post it to this page, I think on June 6th or so. And yeah, so it's kind of a combination. And I would say like with any open source project, there's ebbs and flows. Like there's periods of being really busy, like a really big milestone we hit was the 1.0 release. So we hit 1.0 and 1.1 in like February, March. So there was a major push in the winter to like kind of push us to get to the 1.0, which included the quick methods. And, so we were sprinting for like a good, I don't know, Prema, what was it? Like 5-6, felt like a week and a half.
Yeah. No, we actually did put a lot of effort earlier this year, and then
yes,
things. Yeah, it's been hard, especially with COVID and just things being really busy in general.
That's right. But we are in touch with each other, like, and so we're keeping it going. Like we have very strong Twitter. Follow us on Twitter if you're not. Twitter community out there, and like we were just like mentioned that like there's a data scientist I think in the UK who wrote an article. She mentioned like some unknown or lesser known ML libraries, and like we were listed in one of the top 10, which was on her list, which was cool. So like you know, so like we get, and like we welcome to like try it out, like we're here to say give it a shot, find a data set just like we walked you through, you know, throw it into a Jupyter notebook, and then tweet like see what you can get, see what you can find, like and engage with us, like share your work. We'll retweet it. You know, if you have a question, you can tweet at us or reach out in any number of ways. So yeah, but no, it's always an exciting time at Yellowbrick, and yeah, thank you for the question.
Very exciting. Thank you.
Yes, virtual applause.
No, thank you. We appreciate it. And
Absolutely.
we're glad to, and we're appreciate that you guys, Banjo, that you invited us to present at your meetup.
Yes, thank you so much for having us here.
All right, well, guess we're done for today. I will post the recording when it's up in the meetup channel. So have a good night, everybody.
Okay.
Thanks.
Thank you.
Yeah, have a
Thank
good
you,
night.
Banjo.